Hi, this is Harish here. Welcome to DB2 LUW Tips and Tricks video tutorial part 135. In this tutorial, the topic that I want to discuss is LSN quantum behavior explained. So there is a mystery about quantum behavior of LSN, or the log sequence number, which I had posted in the previous video, the part 134. And in this video, the mystery is unraveled. Okay. The usual things like the scripts that I'm using, the data files that I'm using are freely available for download at db2lewacademy.blogspot.in. My YouTube channel is youtube.com/db2lewacademy. Please subscribe to my YouTube channel, and email is db2academy@gmail.com. This is the usual thing, the disclaimers. There is no affiliation or association with IBM, and I have no access to any internal documentation. So all the whatever the opinions that I'm expressing definitely need verification and confirmation, and these are all speculation based on my test cases. And this is the problem scenario. So as I mentioned before, the video tutorial tips and tricks part 134 is a prerequisite. So if you happen to watch this video for the first time, so I would suggest you to go and look at the 134 number video in the same YouTube page, and then come back to this so that it will make sense. So what I have explained in that 134 is the question that I was trying to answer is whether the log sequence number, is it a measure of space, or is it a space in the sense transactional log space, or is it a number of log records? So definitely I got an answer for that in this video. LSN is a measure of space in version 9.7, and LSN is a measure of number of log records in 10.1 and above. And obviously the latest I'm using 11.1, so that's why I was able to see that discrepancy. And I have also posted this question in iduck.org, the DB2 website, and the forum, and I got a confirmation from there also. The link is available, and I'll also put this in the description. The link will be available in the description as well. And there is and also if you look at see, this is the image that I was talking about, and I'll just show you a better. I'll open the image itself. Like, okay, this is the one. So if you see here, Pixpack 11, the LSN, I did the after test, I did the before test, and I was importing one record of 1 MB blob, 2 MB blob, and 15,000 records, 30,000 records. And 9.7, it behaved, the LSN and the log space were going hand in hand. So it was more of a measure of space here. And in 11.1 modpack 3, fixpack 3, even in 10.1, I think the change is to reflect the number of log records, or the LSN number is going to consume so much of LSN as the number of log records. But I was not able to explain in the previous video. In the previous video, I was not able to explain why it is consuming 64 LSNs instead of 1 LSN here, right? Like you can see that on an average it consumes 64. Here it consumes 128 if I double the data. This behavior was what I was telling, the quantum behavior of LSN. And at last I see some light at the end of the tunnel. Okay, I closed that. Let us go back here. Okay, so there is light at the end of the tunnel. So the explanation for that is one LOB log record. Obviously I'm talking about logged LOB column, and even though you are importing or inserting only one record, it will not consume one LSN. It's consuming multiple LSN because multiple add LOB data log records are generated for inserting or updating that one single LOB column of one record. So because it might be like, see, so the blob column might be 20 MB. It cannot generate one log record of size 20 MB. Instead, it is doing this add LOB data log record. It splits it into chunks of data. And obviously it opens a lot of other questions in terms of recoverability, but I will not go into that as of now. But this behavior, this kind of logging strategy explains the consumption of multiple LSN values, and IBM Knowledge Center also provides corroboration for it. I missed it in the last video to see that. It's my bad. And I have also given you the following link to the Knowledge Center, and we can also look, like I have it in the browser session open here. So you can see that the large LOB object update and insert log records are marked as propagatable, and also it will split into multiple LOB. See, add LOB data and LOB amount log record structure, and there is a lot of reading you need to do here. But after reading this, it was very clear to me that one LOB insert or update is split into multiple LOB log records. That there are two variations of log records. Add LOB data will contain the data also, whereas LOB amount log record will contain only the amount of data that is getting. See, you can see the two different types of log record. So I'm talking about the add LOB data record, which will contain the actual LOB data. This will be the size of the LOB data. Okay, so that's like that. So this will be like mostly used for non-logged LOB columns, wherein it will not log the actual LOB data, but it will just say, like this much amount of LOB data is there, right? Whereas here it will contain the actual logged LOB data as well as the amount. So that's the internal log data. So you can see the LOB data as a character pointer here. So that's the thing that I was telling, and so at last I see light at the end of the tunnel, and the quantum behavior is explained. Hope this information was useful to you. See you in the next video tutorial. Until then, bye bye.